us look at the next question here. Question number 10. Equation of the parabola having focus 3, minus 2 and vertex 3, 1 is, first option, x minus 3 whole square is equal to 12 into y minus 1. Second option, x minus 3 whole square is equal to minus 12 into y minus 1. Y minus 1 whole square is equal to 12 into x minus 3. Y minus 1 whole square is equal to minus 12 into x minus 3. Let's see how it goes. Let us first plot these two, vertex and focus, in a coordinate plane. What is that? Focus is 3, minus 2. Vertex is 3, 1. Let's observe that both of them are on the line x equal to 3. See, we see that the x coordinate is same on this, for this. So both these lie on x equal to 3 line. That's a vertical line. X equal to 3. Now, focus is below the vertex. 3, 1 is here. 3, minus 2 is here. Focus is below the vertex. Therefore, the graph should have been opening downwards. What is the distance between the vertex and the focus? Distance between 1 and minus 2, that is 3 units. Now, when the axis is parallel to the y-axis and the vertex is known and the distance between the focus and the vertex is known as a, x minus h whole square is equal to plus 4a into y minus k or minus 4a into y minus k plus or minus is the equation of the parabola with the vertex as h, k. It is with 4a as the length of the lattice rectum and the vertex being h, k, and whose axis is parallel to y axis here. Okay. Now, what is the vertex here? 3, 1. So, x minus 3 whole square. What is a? A is the distance between the vertex and the focus, and that is 3 units. So, 4 into 3 into y minus k, that is y minus 1. Does it open downwards or upwards? It depends on where is the vertex. Where is the vertex and focus? It's opening downwards here. So, I need to put a minus sign here. So, that makes it x minus 3 whole square is equal to minus 12 into y minus 1. So, the equation is, second option is the right option. Option 2 is the right option, answer. So, the point that we need to know is that when the vertex is h, k, vertex is h, k, and the axis is some x equal to h, axis is a vertical axis, then okay, and suppose the focus is above the vertex, then the equation is x minus h whole square is equal to 4a into y minus k, where a is the distance, this distance. But if the focus were to be below, it's like this, then it would have been, if the focus were to be below, then I would have had a minus of 4a into y minus k. So, that's what we are using here. Okay. So, the right option is option 2. Let's move to the next question. Question number 11. A tangent to y square equal to 7x is equally inclined to with the coordinate axis. Then the area of the triangle formed by the tangent with the coordinate axis is, first option 25 by 16, second option 49 by 32, third option 36 by 25, fourth option 49 by 36. Now, it says that the tangent is, a tangent to this y square equal to 7x is equally inclined to the coordinate axis. What is a line which is equally inclined to the coordinate axis? It has to be either making an angle 135 degrees with the positive x-axis, or it should be making an angle 45 degrees with the positive x-axis. So which means that it actually makes equal intercepts there. Now that means either the slope of that has to be +1 or -1. M is +1 or -1. Slope of the tangent has to be +1 or -1. It has to be with the slope m equal to 1 or -1, and we know that for y square equal to 4ax, a tangent with slope m is y equal to mx plus a by m. Here 4a is equal to 7. That gives me a is equal to 7 by 4. Okay, in our problem 4a is 7, therefore a is equal to 7 by 4. And we said m is equal to +1 or -1. Let us take m to be 1, and what do you get there? You will get y equals to x plus a. That gives us x plus 7 by 4. Y is equal to x plus 7 by 4. I can rewrite it in the form of x minus y is equal to -7 by 4. So we have therefore both the intercepts will be 7 by 4 and -7 by 4. So what will that be? Area will be half into product of the intercepts. So that's going to be 7 by 4 plus or minus, it doesn't matter, because we are putting it in the modulus, 49 by 16, and that by 2, so 49 by 32. Now if the slope were to be -1, I would have got a -1 here, and therefore it would have been plus here, so it doesn't matter there. It could be plus or minus, this could be plus or minus. In either case, the area will be the same, 49 by 32. What is it we are using when if A is the intercept, x-intercept, or capital A is the x-intercept and capital B is the y-intercept, half mod AB gives the area of the triangle formed with the coordinate axis. Okay, so what we get is half into 7 by plus or minus 7 by 4 into plus or minus 7 by 4 and a modulus, that gives us 49 by 32, and that is clearly appearing in the option 2. Option 2 is the right answer. Let's move to the next question. If the line 5x minus 4y minus 12 equal to 0 meets the parabola x square equal to 8y in capital A and capital B, then the point of intersection of the two tangents at A and B is, first option 5, 3, second option 3, 5, third option 4, 6, and fourth option 6, 4. So you have a parabola x square equal to 8y. It would look like this. Now he says there is a line 5x minus 4y minus 12 equal to 0, which is meeting this parabola at A, B. Now the tangents at A and tangent at B, they are meeting at some other point. We are asked to find this point. Let us say the tangents are meeting at some point x1, y1. Now for this point, for this pair of tangents drawn from this point P, this chord will become chord of contact. This is the chord of contact of pair of tangents drawn from P. Tangents drawn from P, Okay. So that what do we know? Whenever s equal to 0 is the equation of the parabola, s1 equal to 0 gives the equation of the chord of contact. This is a fact that we must know, right? To do this problem, we need to know this. Now that is, whenever x1, y1 is an external point to a parabola, we can draw two tangents, and these tangents, let us say they are meeting the parabola at A and B, then this line joining the points of contact is called the chord of contact, and the chord of contact is given by S1 equal to 0. Now how do we write S? What is our parabola in the given equation? X square minus 8y is equal to 0. Let's first transform it into the form of S equal to 0, second degree equation, second degree expression equated to 0. Now how do we write S1? We got to replace x square by xx1, 2y by y plus y1. So here what do we have? X into x1 minus 4 into y plus y1 is equal to 0 is S1. This is our S, this is our S1. That S1 should have been in this line. What are we given about the line AB? So this is AB equation. But AB is already given with some other equation. What was the equation we are given about AB? 5 into x minus 4 into y minus 12 is equal to 0. Let's rewrite this equation as minus 4y1 is equal to 0 minus 12 is equal to 0. Okay. Now these two are representing we are having two equations representing the same line. The coefficients of the like terms must be proportional. So what should we have? X1 by 5 should be same as this is okay, this is matching, and then we have here minus 1 by 1 minus 1, and that is equal to y1 by 4 y1 by minus 4 y1 by minus 12. This cancels here. So from here it's clear that x1 must be 5 equate to this, x1 by 5 is equal to 1, y1 by 12, 4 y1 by 12, that makes it y1 by 3, and y1 by 3 is equal to 1. So y1 is equal to 3. So clearly the point x1 comma y1 must be equal to 5 comma 3. So the right option, as we see, is the option 1. Option 1 is the right option. Let's move on to the next question, question number 13. If two tangents drawn from the point alpha comma beta to the parabola y square equal to 4x be such that the slope of one tangent is double the other, then first option, beta is equal to 2 by 9 alpha square. Second option, alpha is equal to 2 by 9 beta square. Third option, 2 alpha is equal to 9 beta square. And fourth option, alpha is equal to 2 beta square. Now look here. For the parabola y square equal to 4ax, x1 comma y1, if it is an external point, is an external point. From x1 comma y1, an external point. Two tangents can be drawn. Okay, I have an external point x1 comma y1. Two tangents can be drawn from it. Let us say this tangent is given by y equal to mx plus a by m. Y is equal to mx plus a by m. Now he says from the point alpha comma beta we are drawing two tangents. So this alpha comma beta should satisfy both the tangents equation. So what we have is beta is equal to m alpha plus a by m. We get a quadratic in m. So that quadratic in m yields two roots. The two roots are going to be the slopes of the two tangents there. So what do we have here? Alpha m square minus beta m plus a is equal to 0. m1 and m2 are roots which are the slopes of the two tangents. m1 is the slope of this and m2 is the slope of this tangent. Let us say are roots which shall be slopes, which represent slopes. The slopes. Okay, now what else is given about the slopes of the two tangents? Slope of one tangent is double the other. So let's assume that m2 is equal to 2 times of m1. m2 is equal to 2 times of m1. So what can be said about m1 plus m2? That will be 3m1. I'm adding a m1 both sides. Now that 3m1 should satisfy this equation. Or we can even look at this, m1 into m2 is equal to, here we are given the parabola to be y square equal to 4x. That's a given parabola. So a is equal to 1. Okay, so what will be the equation here? The equation could have been written in the form of alpha m square minus beta m plus 1 is equal to 0. What is m1 into m2? 1 by alpha. What is m2 here? 2m1. So 2m1 square is equal to 1 by alpha. But what we know is 3m1 is 3m1 is the sum of the roots. What is the sum of the roots? Beta by alpha. What is the product of the roots? m1 into m2, it is constant by the coefficient of m square here, 1 by alpha. But m2 is equal to 2m1, therefore we have 2m1 square is equal to 1 by alpha here. m1 is beta by 3 alpha, we can substitute that. So 2 into, from this equation, 3m1 is beta by alpha, m1 will be beta by 3 alpha. So 2 into beta by 3 alpha the whole square is equal to 1 by alpha. So that makes it 2 beta square by 9 alpha square is equal to 1 by alpha, and therefore 2 beta square will be equal to 9 alpha. Cancelling out 1 alpha here, 2 beta square is equal to 9 alpha, or alpha is equal to 2 by 9 beta square. So that is clearly appearing in the option 2. So option 2 is right answer. Let's move to the next question, question number 14. A tangent to y square equal to 5x is parallel to the line y equal to 4x plus 1. Then the point of contact is, first option 5 comma 5, second option 5 by 64 comma 5 by 8, third option 5 by 8 comma 5 by 64, fourth option 2 comma 7. Now, I have a tangent to the parabola y square equal to 5x. At some point. This tangent is known to be parallel to y equal to 4x plus 1. Therefore, this is of slope. The slope of this is m, 4. Slope is 4. Now, what we are interested in is this point of contact. Okay, how do we write it? A tangent with slope m is for y square equal to 4ax is y equal to mx plus a by m. That is, let's use this result. So when you have the parabola y square equal to 4ax and this tangent is with slope m, slope is m, then the equation of this tangent is given by y equal to mx plus a by m. Okay. And let's also understand one thing. Let us say x1 comma y1 is the point of contact. Then the same equation can also be written as s1 equal to 0 using this point of contact. So in other words, what we can do is the same mx minus y minus a by m is equal to 0 is one way of writing this equation of the tangent, that is using the slope. And now using the point of contact also we can write the equation of the tangent. What is that? S1 equal to 0. That is, what is S1 equal to 0? S1 is y by 1 minus 2a into x plus x1. S1 is that. So rewriting this equation, 2a into x, see, S1 equal to 0 is the equation of tangent. So 2a into x minus y into y1, y1 into y, okay, plus 2ax1 is equal to 0. I can rewrite the equation like this. Now comparing these two equations, what we have here is 2a by m is equal to y1 minus y1 by minus 1 and that is equal to 2ax1 by a by m. This a cancels and you have here, and this 2. Okay, so what we have here is 2a by m is equal to y1, and that is in turn is equal to 2mx1 by 1. So from here, from the equating the first and the last, what do we have? x1 is equal to a by m square, and y1 is equal to 2a by m. That is, in terms of a and m, we have this point of contact, that is a by m square comma 2a by m. So in our problem, y square is equal to 5x. So this is your 4ax. So a is equal to 5 by 4. 4a is equal to 5, a is equal to 5 by 4. And what is m? M is 1, m is 4 given. The slope is 4. Substituting here in this problem, in this formula, what is a? 5 by 4 divided by 4 square, comma 2a by m. So what is 2a by m? 2a is 5 by 2 by m, that is 4. So what does it make it? 5 by 16 into 4, 64, comma 5 by 8. So that is clearly 5 by 64 comma 5 by 8, 5 by 64 comma 5 by 8, 5 by 8. This is 5 by 4 by 4 square comma 5 by 2 by 4. That makes it 5 by 64 comma 5 by 8. So the option 2 is the right answer. Option 2 is the right answer. Let's move to the next question. Question number 15. Two tangents to the parabola y minus 1 whole square equal to 4 into x minus 2 are at right angles. Then the locus of their points of intersection is, first option, x minus 3 equal to 0. Second option, x minus 1 equal to 0. Third option, 2x minus 1 is equal to 0. Fourth option, 3x minus 1 is equal to 0. Now, let's understand one fact here. Whenever you have two tangents drawn, two perpendicular tangents drawn to the parabola, they meet on the directrix. So this is a fact. Perpendicular tangents meet on the directrix. This is a necessary and sufficiency condition. That is, I will be able to draw perpendicular tangents only from points on the directrix. Okay. So, the locus of point of intersection of perpendicular tangents can be taken as the directrix as well. Here, so y minus 1 whole square is equal to, the given parabola is y minus 1 whole square is equal to 4 into x minus 2, and that's clearly a parabola with the vertex as 1 comma 2. Okay, and what is 4a? So vertex is, 2 comma 1. Vertex is 2 comma 1. Vertex is 2 comma 1. Now, what about the axis? Axis will be the line y minus 1 equal to 0. That is y minus 1 equal to 0. Y is equal to 1. 4a is equal to 4. So, this is 4a. That is 4a is 4, which implies a is equal to 1. We know that the directrix is a line which is at a distance of a units from the vertex, which is perpendicular to the axis. So, 1 unit away from here, what do we have here? So, this point we'll call it as a foot of the perpendicular from focus to the directrix, that is the z point, and that's given by 1 unit away from the vertex. What's 1 unit away from the vertex on this line to y equal to 1? It will be 1 comma 1. Okay, so now this line is a vertical line because it is perpendicular to this horizontal line axis. Therefore, this has to be a vertical line, and this has to be given by x equal to 1. That is, it's a line parallel to the y-axis, therefore, and it's passing through 1 comma 1, therefore it has to be equal to x equal to 1. So clearly, what is asked here, the locus of point of intersection of the perpendicular tangents is known to be the directrix. So what is the directrix of this parabola? It's x equal to 1. Therefore, the required locus is x minus 1 equal to 0. That is the directrix of the given parabola. So the point that we have to bear in mind is the locus of point of intersection of perpendicular tangents is the directrix. And in fact, there is also one more result. The chord of contact of a pair of perpendicular tangents will have to be the focal chord. Of course, that may be used in some of the problems. That is, the chord of contact of a pair of tangents which are perpendicular. Of course, they have to be drawn only from a point on the directrix. So, and that chord of contact is going to be passing through the focus, and that therefore will be a focal chord. Okay, right. So option 2 is correct. Option 2 is correct. So let's move on to the next question. Question number 16. Two common tangents to the circle x square plus y square equal to 2a square and parabola y square equal to 8ax are first option x equal to plus or minus y plus 2a, y is equal to plus or minus x plus 2a. Third option x is equal to plus or minus y plus a, y is equal to plus or minus x plus a. This is the fourth option. So let's have a look at how to go about this equation, this problem. X square plus y square is equal to 2a square. I can write it in the form of root 2a whole square. Now, y square is equal to 8x. That I can write it in the form of 4 into 2 into x. ax. 4 into 2a into x. So we are trying to bring it into standard forms like this. X square plus y square is equal to r square. Y square equal to some 4ax. A tangent to this, tangent with slope m, is equal to y equal to mx plus or minus the radius times, that is a root 2 times root of 1 plus m square. That is, for the circle x square plus y square equal to r square, a tangent with slope m is given by y equal to mx plus, with origin as a center, or r is a radius, y equal to mx plus r root 1 plus m square plus or minus. Similarly, for a parabola y square equal to 4ax, a tangent with slope m, this tangent is given by the equation y equal to mx plus a by m. So y equal to, in this case, what is in place of a? 2a. So y is equal to mx plus 2a by m. Now we want to know for what values of m these two are same, because we are looking for common tangents. So for what values of m these two are same, that means these two have to be equated. That is, a root 2 into root 1 plus m square should have been equated to 2a by m. So let us cancel out this a and let us square both sides. What do we have? 2 into 1 plus m square is equal to 4 by m square. So what we have here is we therefore have 2m square into 1 plus m square is equal to 4. So 2 can cancel and we have this. So m square, if I put it as some lambda, let us put m square as lambda and solve for lambda here. Lambda into 1 plus lambda, that is lambda into 1 plus lambda minus 2 is equal to 0. So that is lambda square plus lambda minus 2 is equal to 0. That gives me lambda plus 2 into lambda minus 1 is equal to 0. So that gives us lambda to be, but lambda cannot be, lambda plus 2 cannot be 0, because if lambda plus 2 were to be 0, it means that m square plus 2 is 0, which is never possible for any real value of m. So this is not 0. So your m square has to be therefore 1. So m has to be therefore plus or minus 1. Therefore, what is it you can say? M is equal to plus or minus 1. So the tangent with slope 1 or minus 1 is going to be common tangent to both the circle as well as the parabola y square equal to 8ax. So I have to take plus y is equal to plus or minus 1. I mean m is equal to plus or minus 1. Therefore, the tangent will now be, tangent equation will be y is equal to, instead of m, let us write plus 1 or minus 1. So plus 1 or minus 1 into x plus 2a plus or minus 1 here. So what do I have here? Y is equal to x plus 2a is one of the possibilities when I am taking a plus sign in both cases. Other possibility is y is equal to minus x minus 2a. And this is clearly appearing in the option 2. So y is equal to, combining these two, I can write y is equal to plus or minus x plus 2a. That is, if I take plus sign in both cases and minus sign in both the terms, that is y is equal to plus or minus x plus 2a. That is clearly appearing in the option 2. Therefore, option 2 is the right answer. Let us move on to the next question, question number 17. If a is not equal to 0 and the line 2bx plus 3cy plus 4d is equal to 0 passes through the points of intersection of the parabolas y square equal to 4ax and x square equal to 4ay, then first option d square plus 2b plus 3c whole square is equal to 0. Second option d square plus 3b plus 2c whole square is equal to 0. Third option d square plus 2b minus 3c the whole square is equal to 0. Fourth option d square plus 3b minus 2c the whole square is equal to 0. We are given if 2bx plus 3cy plus 4d is equal to 0. That's a line which is passing through the intersection of y square equal to 4ax and x square equal to 4ay. These are the two parabolas. Y square equal to 4ax is a parabola with the vertex as origin and whose axis will be x-axis. X square equal to 4ay is a parabola like this. They both intersect in 2 points. In fact, we will easily be able to see that by putting y is equal to 4ax here, we will get x square to be equal to 16a square. So 4a comma 4a is one of the points, and other point of intersection is 0 comma 0. This line passes through this 2bx plus 3cy plus 4d is equal to 0 is a line passing through these two. So this is the given line, but that's clearly, what is that line? Okay, right, what is that line? Let's call this as O and A. This line OA is clearly y is equal to x. You see that OA is this line. OA is equation of OA is x minus y equated to 0. But that OA equation is also given by, this is given in the problem. So now comparing 2b x plus 3cy plus 4d is equal to 0. So clearly from here your d must have been 0 because These two are to represent the same line. So D must have been 0. And what is it I can say here? We must have 2B by 1 is equal to minus 3C by minus 1. Okay, and we therefore have 2B minus 3C is 0, so 2B plus 3C is 0. And also we have D to be 0. D is 0 and 2B plus 3C is both 0. Both these expressions are 0. That can be possible if and only if D square plus 2B plus 3C the whole square is equal to 0. When the sum of the squares of two real numbers is 0, it means that both the numbers have to be 0 simultaneously. So we have D to be 0 and 2B plus 3C equal to 0. That can be combined into one condition this way: D square plus 2B plus 3C the whole square has to be 0, and that's clearly appearing in the option number 1 is the right answer. Let's move to the next question, question number 18. Let P be the point 1, 0 and Q be a point on the locus y square equal to 8x. Then the locus of midpoint of PQ is, first option, y square minus 4x plus 2 is equal to 0. Second option, y square plus 4x minus 2 is equal to 0. The third option, x square plus 4y plus 2 is equal to 0. And the fourth option, x square minus 4y plus 2 is equal to 0. Now, P is a point, some 1, 0. We have a parabola, y square equal to 8x. That is a parabola with vertex as origin. Okay, and the axis is x-axis. X-axis. 1, 0 is some point P that's given to us. Says there's a point Q that is moving on the parabola. P is this point, Q is moving on the parabola. This is a variable point on the parabola or moving point on the parabola. For different positions we'll have Q moving like this. We are interested in the locus of the midpoint of this here. Let us say R is the midpoint of any one of the possible positions of Q, P and Q. P is of course fixed 1, 0. So now clearly, okay, now how do I get the coordinates of Q? 2 times the midpoint minus 1 extreme will give me the midpoint, will give me the coordinates of the other. So what is it we have? 2x1 minus 1. Let's write the coordinates of Q. 2x1 minus 1, comma 2 into y1 minus 0. That is twice the midpoint. R we are assuming as the midpoint of PQ. So twice the coordinates of the midpoint minus one end will give me the other end. So we are writing that. But then this has to be a point on the parabola. Which is the parabola? Y square equal to 8x. So this has to be taken as y and this has to be taken as x, and then we'll write y square is equal to 8x. What is y square? 4y1 square. Y square is equal to 8x, as this point Q satisfies that. But Q coordinates are these. So 4y1 square is equal to 8 into 2x1 minus 1. So your x1 comma y1 satisfies this equation. Let's substitute, let us cancel out this 2 here. So what we have is locus of x1 comma y1 is y square is equal to 2 into 2x minus 1. 2 into 2x minus 1. That is y square minus 4x plus 2 is equal to 0. Y square minus 4x plus 2 is equal to 0 there. And that's clearly appearing in the option. Option 1 is the right answer. Let's move to the next question, question number 19. The locus of the vertices of the family of parabolas y equal to a cube by 3 into x square plus a square by 2 into x minus 2a is, first option, x into y is equal to 105 by 64. Second option, x into y is equal to 3 by 4. Third option, x into y is equal to 35 by 16. And fourth option, x into y is equal to 64 by 105. The parabola, the family of parabolas are given by y equal to a cube by 3 into x square plus a square by 2 into x minus 2a. Now let us note one thing here. Whenever you have a parabola y equal to some ax square plus bx plus c, this is a parabola. This parabola, we know that it has its axis parallel to the x-axis, sorry, y-axis. Its axis is parallel to the y-axis, and that is given by x equal to minus b by 2a is the axis. The vertex is given by minus b by 2a comma 4ac minus b square by 4a. Vertex is, this is the vertex. This point is the vertex, and that is given by the coordinates minus b by 2a comma 4ac minus b square by 4a. So for this parabola y equal to ax square plus bx plus c, we have this as a result. This can be actually arrived at this also. Now whenever a is positive, you will have a minimum at x equal to minus b by 2a, dy by dx is to be 0, d square y by dx square will have to be positive at that point. You can easily find out, putting x equal to minus b by 2a, you will get the y coordinate as 4ac minus b square by 4a. So here, now, okay, now going by comparing with this, instead of a we have a cube by 3, and instead of b we have a square by 2, and instead of c we have minus 2a. So keep writing it. Now what is the vertex now? Let us say the vertex is some x1 comma y1. So what is it, x1 comma y1? x1 is equal to minus b by 2a, that is minus of the coefficient of x by the coefficient 2 times the coefficient of x square, minus of the coefficient of x by the 2 times the coefficient of x square. So minus of a square by 2 by 2 times the coefficient of x square. What is that? 2 times a cube by 3. So what do we have now? 1 a square will cancel and you will be left with a here, and what do we have? Minus 3 by 4a. Minus 3 by 4a. Clearly we are left with a here, okay, and this 3 goes up and you will have a minus 3 by 4a. So that is the x1. What about the y1? y1 is given by 4 times product of a into c. What is a? The coefficient of x square. So that is, in place of a we have a cube by 3 into, in place of c what do we have? The constant term is minus 2a minus b square. Instead of b what do we have? A square by 2, the whole square, by 4 into a, that is the coefficient of x square again, that is a cube by 3. So what is that y1 going to be? We'll have to simplify this. That makes it minus 8a power 4 by 3 minus a power 4 by 4 okay, and by 4a cube by 3. So that is your y1. Implies y1 is equal to this. So we have an a cube that cancels out here. A cube can be cancelled out. So you will be left with a here, and minus can be taken common, and we have a LCM as we have here 12. LCM minus taken common. So we have therefore 4 into 8a, 32a plus 3 into a, that is 35a, and you have here 3 by 4, because 4 by 3, when I take it up it will be 3 by 4. So what do we have here? Again further we have a 3 cancelling and 4 here. So that makes it minus 35a by 16. So y1 is equal to minus 35a by 16. And what did you find x1 to be? Minus 3 by 4a. x1 was minus 3 by 4a and y1 is equal to 35a by 16. From these two we can actually multiply these two, and what do we get here? From here x1 into y1 will be equal to 105, 3 into 35, 105, and this 4 into 16, 64. So x1 into y1 is 105 by 64. So therefore the locus of x1 comma y1 is x into y is equal to 105 by 64. So the fact that that's clearly appearing in the option 1, option 1 is the right answer. So option 1, this is appearing in option 1, option 1 is the right answer. Now that one thing that we'll recall is, for the parabola y equal to x square plus bx plus c, x equal to minus b by 2a will be the axis of symmetry. It can be opening upwards or downwards, we do not know, it depends on a. If a is positive, it opens upwards, a positive, it opens upwards, a negative, it opens downwards. However, the axis of symmetry is going to be x equal to minus b by 2a, and the vertex will be minus b by 2a comma 4ac minus b square by 4a. So this is a fact that we need to remember, and from there it's a routine thing to do. Okay, right. So for option 1 is the right answer. Let's move to the next question. Question number 20. The equation of a tangent to the parabola y square equal to 8x is y equal to x plus 2. The point on this line from which another tangent to the same parabola is perpendicular to the given tangent is, first option minus 1 comma 1, second option 0 comma 2, third option 2 comma 4, and fourth option minus 2 comma 0. So let's have a look at this. Y square equal to 8x, a parabola with the vertex as origin and standard axis as x axis. Y square equal to 8x. Focus will be 2 comma 0, comparing with 4 into ax, a is 2, so a is 2, 2 comma 0. The directrix will be 2 units away from here, so that is, this is 2 units, therefore I will have directrix to be x equal to minus 2. Now we are given some tangent which is at the form y equal to x plus 2. So it has a slope 1 there. Now he says there are various points on this tangent. From where should we draw another tangent to the same parabola so that the two tangents, this tangent and the other one, will have to be perpendicular? We know one fact, that perpendicular tangents meet on the directrix, and perpendicular tangents can be drawn only from points on the directrix. So where this line is meeting, where this tangent at P, at some point P, is meeting the directrix, from that point we will be able to draw one more tangent which will be perpendicular to this tangent. So the point at which that given tangent meets the directrix will be the point from which point on the given line from which we will be able to draw the another tangent which will be perpendicular to it. So what is it? What I have to do is I just have to solve this with y equal to x plus 2 has to be solved with x equal to minus 2. Solve with x equal to minus 2. So when I put x equal to minus 2, what do we get? It implies y is equal to 0. So minus 2 comma 0 is the point, is this point, from where the other tangent will have to be perpendicular to the line y equal to x plus 2. So clearly that is appearing, option 4 is the right answer. Let's move to the next question, question number 21. The shortest distance between the line y minus x equal to 1 and the curve x equal to y square is, first option 3 root 2 by 8, second option 2 root 3 by 8, third option 3 root 2 by 5, fourth option root 3 by 4. Y minus x is equal to 1 or y is equal to x plus 1. And what is he given? X is equal to y square. Okay, or y square is equal to y square is equal to 4 into 1 by 4 into x. A common normal between two curves will be the line of shortest distance. So here I can treat this as one curve C1, another curve C2. Okay. Now, so what we do is we draw a normal to both these curves. What will be a normal to this curve having slope as minus 1? Because this is with the slope 1. Therefore, the normal to this, normal to y equal to x plus 1 is of slope minus 1. Okay. Now, we will write the equation of normal to the parabola y square equal to 4ax at, with slope minus 1. Normal to the parabola y square equal to 4x with slope m is given by y equal to mx minus 2am minus am cube. And the point where normal is drawn is am square comma minus 2am. That is, when you have the parabola y square equal to 4ax, a normal with slope m, this is a normal with slope m, it's a normal to some tangent. The normal with slope m, this is a slope, this normal is given by y equal to mx minus 2am minus am cube. And this point where you are drawing the normal will have to be given by am square comma minus 2am. This is a fact one needs to know. So that is used here, am square comma minus 2am. What do we have in place of a? 1 by 4. Okay, and what do I have in place of m? Minus 1. So what is the normal? Y is equal to minus 1 into x minus 2 into 1 by 4 into minus 1 into minus 1 by 4 into minus 1 cube. So that makes it minus x plus 1 by 2 plus 1 by 4. So that makes it here y x plus y is equal to 3 by 4. X plus y is equal to 3 by 4 is a common normal, right, for the line y equal to x plus 1 and the line and the curve y square equal to x. What is the foot of the normal? So I have a line like this, I have some line like this, a normal to this and also normal to this. So I can find out that. So what is that? Okay, this normal, common normal is given by x plus y is equal to 3 by 4, and this point that you have here is, the point is, what is that point? Am square comma minus 2am. So 1 by 4, this point 1 by 4 into minus 1 square comma minus 2a, that is 1 by 4 into minus 1. So that makes it 1 by 4 comma 1 by 2. So this point is going to be 1 by 4 comma 1 by 2. The point from where a common normal is drawn is 1 by 4 comma 1 by 2. Okay. So you can find out the distance between 1 by 4 comma 1 by 2 to this line y equal to x plus 1. Y equal to x plus 1. We could have done the same problem in a different way, that is, I just draw a tangent which is parallel to y equal to x plus 1 to the parabola and find the distance between the these two parallel lines. That will also give us the shortest distance. So it is clearly, what is that shortest distance? It's given by the common normal. And what did we find as the common normal? X plus y equal to 3 by 4. What is the point at which that is meeting the, where the normal is drawn at to the parabola y square equal to x? It's drawn at 1 by 4 comma 1 by 2. So distance from 1 by 4 comma 1 by 2 to y equal to x plus 1. We'll use the distance formula. So what is that? X minus y plus 1 equal to 0, and 1 by 4 comma 1 by 2. From here we need to find the perpendicular distance. So what is that? 1 by 4 minus 1 by 2 plus 1 by under root 2, modulus of this. That gives the perpendicular distance there. How much is that? This makes it 5 by minus 1 by 4, and 1 minus 1 by 4, that's 3 by 4. 3 by 4 root 2. Okay, 3 by 4 root 2 is the distance, or we can even write it as 3 root 2 by 8. We can write it as 3 root 2 by 8. The right option is option 1 is the right option. So although this was a generalized procedure that I had given to you, here we could have done the problem in a very short manner like this. I will redo the problem in the method 2. Method 2. So what is it? We have the parabola, we have a line like this. We want the shortest distance between the line and the parabola. So what you do is you draw a tangent parallel to this. What is the slope of this line? Y equal to x plus 1, slope is 1. So take a tangent with slope 1. Okay, what is the tangent with slope 1? Y is equal to 1 into x plus a by m. What is a? This, it's in the form of y equal to 4, y square equal to 4 into 1 by 4 into x. So a is equal to 1 by 4, and what is your m? 1. So y is equal to x plus 1 by 4. So what is it? I have taken m to be 1. I have reused the formula y equal to mx plus a by m. That is a tangent with slope m for the parabola y square equal to 4ax. So we've used that. Therefore I have drawn a parallel tangent to this. Now I just find out the distance between these two parallel lines. Y is equal to x plus 1 by 4. Y equal to x plus 1, y is equal to x plus 1 by 4. These two are the two parallel lines. What is the distance between them? Distance between is given by 1 minus 1 by 4 by under root of 2. So that makes it 3 by 4 root 2, which is nothing but 3 root 2 by 8. So this could have been done in 2 steps like this, but I gave you a general procedure, that is how to find the distance, shortest distance between two curves. It is given by the common normal. So what we have done was we found a common normal and we found the point of contact of where that common normal is drawn to the parabola, and from there we found the distance from that point to the line, given line y equal to x plus 1. So this could have been done in 2 steps like this, finding a tangent which is parallel to it and finding the distance between those two tangents, those two lines. So that's it. So clearly option 1 is the right answer.